Hello, this is Garrett Keane. In this video I'm going to show you how to distribute the misclosure error after carrying out a levelling survey and having reduced the levels using the rise and fall method. So you can see in this example it's a completed survey. The backsides, intersides and foresides have been measured out in the field, and then you process the results or reduce the levels using the rise and fall method. The first thing you need to do is to work out what the misclosure error is, and then to work out the adjustment for each time you set up the instrument. So to do this, you come over to this frame over here, and the benchmark of the last reading, you come down to your comments column and you come to the very last reading, and you have a benchmark here which has a reading of 28.225. So when you get to this point, that's the exact measurement for the reduced level, or a very accurate measurement set up by the Ordnance Survey of Ireland. Then the next thing you do is to calculate from your survey what was the last calculated reduced level. So you come over to this column here and you come to the very end, and you can see when you got back to this Ordnance benchmark here and calculated the reading, you got a reading of 28.232, a reduced level of 28.232. So you can see from here that your reading is 7 millimeters too high if you subtract the benchmark reading from the last calculated reduced level. Now, with this misclosure error, you have to distribute it between all the times the instrument or the level has been set up. So to calculate the number of times it's been set up, you come to it's the number of change points plus 1. The 1 corresponds to the first time you set up the instrument, which is here, and then you have a change point here. You know it's a change point because you have a backsight and a foresight. So this is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. So you have 6 change points, and that means 6 plus 1 gives you 7. You've set up that instrument 7 times. So you can see that the error, or the adjustment for each time you set it up, is 1 millimeter, but you're 7 millimeters too high, so that adjustment has to be negative. So it's 0.007 divided by 7. So the adjustment for each time the instrument is set up is minus 0.001 meters, or minus 1 millimeter. So I'm just going to process this column first of all, just to say here that you have a temporary benchmark here, which is 30.500. It's a value where you know the reduced level, therefore you make no adjustment onto that one because you know it should be correct. So you start working out your adjustments on from the second row on. Now the first adjustment, you've set it up once, is minus 0.001, but this column contains cumulative adjustments. So if you come across here, the way you actually work out the adjustment on the next line is to scan across and see, is this a change point? It's a backside and a foresight together, therefore it is a change point. Therefore you increase the cumulative adjustment by this amount down here. So the adjustment now is 2 millimeters. To figure out what the adjustment is on the next line, scan across. On this line, do we have a change point? Yes, we do. Therefore we increase the adjustment, the cumulative adjustment, by this amount again. Now to figure out the adjustment on the next line, scan across. It's an intermediate site, so we leave the cumulative adjustment as it is and make no change. Likewise, we come across to the same line here. It's an intermediate site, so we basically make no change to the cumulative adjustment. Come across here. No, it's an intermediate site, so on the next line we make no change. But now we come across here, we have a change point, so we increase the cumulative adjustment because we've set the instrument up another time. So at this stage, the instrument has been set up 1, 2, 3, 4 times, so our adjustment is 4 millimeters. We scan out. Keep a note that every time you have a change point, you increase the cumulative adjustment, but you do it on the following line. So we come across here, we have a change point, so we increase the cumulative adjustment up to 5 millimeters. We scan across. It's an intermediate site, so we leave the adjustment as it is. Likewise here, it's an intermediate site, we leave it as it is. Likewise here in this line, it's an intermediate site, so we leave it as it is. Now we have a change point, so we increase it on the following line. Likewise here, we have a change point, so we increase it on the following line. Here we have an intermediate side, so we leave the adjustment as it is. So the basic rule is, if you have an intermediate side, you leave the adjustment unchanged on the next line. If you have a change point, you increase the cumulative adjustment on the next line by whatever this value is here. So now that I've worked out the adjustments, I come over here to this reduce level, and I'm going to reduce this one by 1 millimeter. This one here, I'm going to reduce by 2 millimeters. This one here, I'm going to reduce this by 3 millimeters. This one here, I'm going to reduce by 3 millimeters. This one here, I reduce by 3 millimeters. Once again, it's 3 millimeters, so it's 172. This one by 4 millimeters, 29.696. This one I reduce by 5 millimeters, so it's 584. This one is by 5 millimeters, 761, sorry. This one I reduce by 5 millimeters, so it's 29.825. This one is by 5 millimeters, so it's 29.172. This one is by 6 millimeters, so it's 28.526. This one is by 7 millimeters, so it's 28.304. And this one is by 7 millimeters, so it's 28.225. And you can see now that your reduce level here matches the Ordnance benchmark reduce level. I have this application set up so that you should get a green tick if it's correct, and that shows when we save the task, it gives us a green tick if everything is correct. Okay, thank you very much for listening.